Good day, maayong adlaw kanyang tanan. Today we'll be having a new topic in quantitative methods. Basically, it's not a new topic. We already have encountered this in many subjects and many courses, especially on mathematics and statistics. So we need to review ourselves on the different sampling methods or sampling techniques that we conduct in order to get the sample out of the population. By definition, sampling is a process used in statistical analysis in which there is a predetermined number of observations, numbers, or any data which are taken from a larger population. So there is basically a population that is identified, and you will take out a small portion of it. So we call that process as the sampling process or sampling. So an example, let's say for example, we'll be getting a 500 student sample out of the population of high school students in Panabo City. So we get a sample of 500 students out of those population. So the small group basically is called sample, and the larger group, which the generalization is made, is called the population. So we already defined that a population is defined as all members of any well-defined class of people, events, or objects. So mostly peoples because of our respondents or participants of the study. So let's say, for example, there are 300,000 high school students in the region 11. So that is basically your population. And we get a portion of those 300,000 as your sample of your respondents or your participants of your study. We do have what we call a census or complete enumeration. This is the complete count of every unit, of everyone or everything in a population. So if there are 300,000 high school students in Region 11, so that, and then you want to study the entire 300,000, so you are using what we call a census or complete enumeration. It is where all members of the whole population are measured based on your research instruments and based on your research procedures. One disadvantage of complete enumeration is it is very expensive and very time consuming because you need to reach out the entire population in order to get the data or their responses of your research instrument. So there are steps in sampling. So first is basically you need to identify the target population. Second is you need to make a distinction between the target population and the population that is accessible to the researcher. Third is to select the sample using two techniques. You could do it in what we call as probability sampling, and second is non-probability sampling. So probability sampling is wherein every element in the population has a non-zero probability of being selected. So they are selected in random and they have equal chance to be selected. Non-random sampling or non-random or non-probability sampling or non-random, um, the sample or the people persons to be selected do not know in advance how likely that any element of the population will be selected for the sample. So there is no equal chance. So we will explore later the different techniques in probability sampling and non-probability sampling. So we'll start with probability sampling. So before we will discuss the different types of probability sampling, we need to understand that you can get your sample size in many ways. One way is through the Sloven's formula. Sloven's formula is used to calculate the sample size, small letter n, given the population size, larger n, and a margin of error. It is a random sampling technique wherein in order to estimate the sampling size. So this is the formula of the Slovenes getting the sample size. So it is n, divide it by the sum of 1 and the product of the population n times the square of the margin of error. Okay, so n is basically small letter n is the sample size. That's our target, and we need to get. And then this larger n is the population size. E is the desired margin of error. So you will be the one to decide what is your margin of error based on your confidence level. Example, you have a confidence level of 95%. That means your error level is 5%. So it means that your margin of error is 0.05. So let's have an example in order to illustrate the Sloven's formula and the process of getting the sample. First, we do have a population of 1,000 and our margin of error is 0.05. It is to understand that our confidence level is 95%. Then we will use the formula 1,000 divide 1 plus 1,000 times the square of 0.05. So upon calculation of the sample size using this formula, so we get 285.7142. So we need to round it off to whole number because there is no object or person with fractional part. Wala naman sigurong 0.5 na tao. So we need to round it off to the nearest whole number. So that means your samples is 286. Your sample size is 286. So I want you to do an activity on your own. So a researcher plans to conduct a survey in Panabo City. If the population of the city is 174,364, find the sample size with the margin of error of 15%. That means your confidence level is 85%. So we'll start with the first type of probability sampling, which is simple random sampling. So simple random sampling is basically the most common random sampling or probability sampling. So you just get a sample from the population either systematically or using the Sloven's formula. So after you define the population, you assign each member of the population a distinct identification number. So like this illustration, each unit of the population do have a distinct number. And then you need to select the sample by employing a procedure wherein random chance, through random procedure, it will determine the members of the sample drawn. So you could do it systematically or you could do it in mathematical or computation using Sloven's formula. So this is an example I will read. A researcher wants the study of effects of virtual gaming with academic performance of high school students in Panabo City. So let's say there are 25,000 high school students in the city and you will use Sloven's formula to get the sample size. And your confidence level is 95%. So we understand that the population of high school students is 25,000 and our margin of error is 0.05. It is acquired based on our defined confidence level, which is 95%. So this is our Sloven's formula, and we just substitute all the available values to our formula. So 25,000 divided 1 plus 25,000 times square of the 0.05. And our result is 393.7. And we need to round it off to the nearest whole number. So our sample size is 394. Okay, so that is your sample size. Another type of probability sampling is the stratified sampling. So in stratified sampling, you basically divide the population into subgroups, which is called strata, that may differ in the different characteristics being studied. It is often desirable to use this kind of form, which is stratified sampling. So the population is divided into groups called strata. So we do have strata 1, strata 2, strata 3, and strata 4 in our example. And we will conduct a simple SRS, or simple random sampling, using systematical procedures or using the Sloven's formula on each strata. And then you combine each of those, and that is your sample. So divide the population into some population, which is strata. So you make a table representing your strata, and then from each stratum you obtain a simple random sample of size proportional to the size of the stratum, using this formula, which is sample size of the strata is equal to the size of the entire sample, divide the population size times the strata size. And then step 3, use all members obtained in step 2 as the sample. So basically, those are your sample of each strata, or of each subpopulations. And then you perform a simple or systematic random sampling in choosing the units to be represented in the sample of each strata. So example, you work for a small company of 1,000 people and want to find out how they are saving for their retirement. So you use stratified random sampling to obtain your sample. So the population will be divided in strata by age groups. So there are 5 age groups. We do have 20 to 29, 30 to 39, 40 to 49, and 50 to 59, and 60 plus. So this is the total number of people in your strata, and each strata is represented with this value of people. So again, our strata is based on the age range. So we will now obtain the sample using the Sloven's formula with 98% confidence level, and the sample is 714. So we understand that our sample size is 714. So after obtaining the sample size, we'll now proceed on computing the proportion from each group. Okay? So in group 20 to 29, you get the sample size 714. 714 is our sample size. Divide 1,000, which is the population size, times the number of people in the strata. So it's 114.24, round it off to the whole number, which is 114. In the age group 30 to 39, 714, divide the population size of 1,000 times 220, 157.08, and round it off to 157. And then so on until to the last age group, which is 60 plus, and your strata sample size is 129. So take note, if you will add all of the strata sample size, it results to our sample size of the population, which is 714. Another type of probability sampling is cluster sampling. So in cluster sampling, basically it's similar with stratified sampling, wherein the groups are divided into subpopulation called clusters. So you basically divide it based on their characteristics, or based on your research procedure. Now in our illustration, there are 4 clusters, and in cluster sampling, you just select, you know, the entire, you just select groups out of the 4 groups, and then what the groups that are selected is basically your sample. So you just add up the numbers of group 1 and group 4, and that is your sample. So there are 2 types of cluster sampling. First is the one-stage cluster sampling. So it occurs when the researcher includes respondents from the population, respondents or population from all the randomly selected clusters as sample. So we do have here a example problem. A researcher divides the population of Davao del Norte into groups by municipality and cities. He then selects a number of groups, and the population of those selected groups are the sample. You need to find the actual sample using one-stage cluster sampling. So this is the table of our. So it is important, you need to create a table of your clusters and the size of each clusters. So you need to determine the population and the size of each clusters. Then the researcher will select a number of clusters depending on his research. It could be through systematic random sampling, or simple random sampling, or through researcher discretion. In this case, this will be through researcher discretion. He selected 4 clusters through random sampling. So, example, he conducted random sampling out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11 municipalities and cities in Davao del Norte. So he selected 4 clusters in Asuncion with 59,322 population size, Capalong 76,334 population size, New Corelia 54,844 population size, and Tagum City, which has 259 for 444 population size. So all of the population of the selected clusters will be the sample. So 59,322 plus 67,334 plus 54,844 plus 259,444. So the sample size for the research is 449,904. It's relatively still large, in comparing it with the total population, which is 1,016,332. It's almost half of the population. So basically, we tend to use the 2-stage cluster sampling in order to filter out the sample size resulted from the 1-stage cluster sampling. So we'll proceed basically on 2-stage cluster sampling, wherein the researcher still selects number of respondents from each cluster by using simple or systematic random sampling. So we will take our example in our 1-stage cluster sampling. So once we have selected the clusters, we will conduct random sampling on the population of each clusters using Sloven's formula. with 95% confidence level. So that means our margin of error is 0.05. So taking out the example in our one-stage cluster sampling, so using the Sloven's formula, we have computed the sample size on each clusters. So 397, 398, 397, 399. And when you sum up all the sample size on each clusters, it is 1,592. So if you will compare it from our original sample size from our one-stage cluster, it is relatively smaller than the population sample size using the one-stage cluster, which in the two-stage cluster sample is 1,592. So as you notice, it is basically relatively small. So it is still acceptable because it undergone a systematic cluster sampling, and 1,592 is acceptable as the sample size from the 1 million population of Davao del Norte. But you need to strictly follow that you can only get 397 from the Asuncion cluster and 398 from Kapalong cluster, and so on. So the researcher must be strict on his or her procedure, in getting respondents or participants of the study based on the computed sample. Another type of probability sampling is the systematic sampling. Basically, it is a method of selecting every nth element, or we call that as the skip, or respondents from the population. So when you already know the sample, the systematic selection will follow. So you decide how many subjects you want in the sample using researcher description, let's say 50% technique, or the Sloven's formula. For example, let us assume a total population of 500 subjects and a desired sample size of 50. So 50%. Sample size of 50. Let's say you have computed it using a formula. So to get the skip or the nth element, so you divide 500 subjects divide by the 50 sample size. So your skip is 10. So that means you will select elements or persons or respondents on your research every 10th on the population. Again, when you conduct a systematic sampling, it is important that each population is assigned with an identification number that is unique. And then based on those, you will select every 10th member of the population, and that is your member of the sample size until you get the 50 sample size. Let's say, for example, your sample size is 25 and your skip is 3. So every third member of the population, based on the counting, will be part of the members of the sample until you reach 25 sample size. Next is non-probability sampling. So one type is convenience sampling. So in convenience sampling, it's one of the weakest sampling technique. So those participants or respondents or elements that are present during the conduct of the research visit, it will be he or she will be chosen as respondent. Example, getting responses from those who are present in the school campus during a specific period for a mobile application friendliness survey. So if you have reached out 30 people, okay, around the campus, So that is basically your sample. So that is your convenience sampling. So upon arriving to the research site, okay, or your survey site, those who are present during that time of your visit, that is basically your sample. Okay. So again, this is non-random sampling because the selection is not randomly selected, or the sample members are not randomly selected. Next type is purposive sampling. So sample elements judged to be typical or representatives are chosen from the population. Example, a team of researchers wanted to understand what is the significance of programming skills to software developers. So their characteristics requirements of their respondents are software developers. So they basically ask programmers and developers about this. Okay, so this is purposive sampling. So there are combinations of random purposive sampling wherein, sample purposive sampling wherein you get the sample size. Let's say, for example, your sample size is 60, and then your purposive, based on your purposive characteristics, which are programmers and developers, so you need to reach 60 of the programmers and developers. But that is unlikely to happen due to the fact that it will be biased and it will not become random. Okay? Next is quota sampling. It involves selecting typical cases from diverse strata of a population. So the quotas are based on known characteristics of the population to which you wish to generalize. So it's similar with stratified sampling wherein you need to quota. You need to reach the quota of your required research in your research. Example, an interviewer may be told to get a sample of 200 females and 300 males between the 45 and 60 ages or years old. So this means that the individuals can put a demand on who they want to sample targeting. So the researcher just need to target a quota on each strata, and then he or she needs to reach out, let's say 200 females of the 45 to 60 age group, and then 300 males to 45 and 60 age group. Okay, so that ends our discussion of the sampling techniques. So you can, this is just a supplementary for our module, and the module are available in our learning management system. So thank you for listening. I hope you learned something today.